Hello, welcome to Math with Beth, and today we are going to do derivatives. We're going to look at derivative notation, the power rule, and the sum and difference rules. All of these are the basic principles of finding derivatives. So first, you probably have already looked at the difference quotient, which is the long form of trying to find a derivative. But we're now going to look at some of the notation. So f prime of x, that little apostrophe we call prime, is one way to say the derivative of f. Y prime means the derivative of y. So these are the same because f of x and y are the same. dy dx is another way to say the derivative. And d dx f of x. So unfortunately, there's a lot of different notations, so it's good to just know them all and not think that these mean different things. So all of these mean finding the derivative. So if they asked you something like this for the function q equaling g of t, write 4 different notations for the derivative of q with respect to t. So right now we're not doing any math, we're just practicing the notation. So q prime would be one way to say the derivative of q. G prime of t would be another way. dq dt would be another way. And d dt of g of x would be the 4th way. So these are just 4 different ways to say the derivative of q. Okay, now into the work. The first rule you need to understand when finding derivatives is just the power rule. So if you have a function that is x raised to some power, then the way you find the derivative of that is the power comes out front. So see how this k came to the front. You still have the x, but now the exponent changes by subtracting 1. So again, with all the letters, this looks a little more complicated than it is. So let's just do a couple to show you. In this case, if I wanted to find y prime, the 5 comes to the front, and now I subtract 1 from the power. That's it. So that would be the derivative. So instead of using the whole entire quotient rule to try, or not quotient rule, but the difference quotient to find the derivative, I can now use this shortcut and get it in 2 seconds. Let's try another one. Remember that if nothing's there, it's really a 1. So the 1 would come in front, and x would be raised to the 1 minus 1, which is 0. Since x to the 0 is 1, the answer would just be 1. So that is the derivative, 1. And then finally, if you have something like this that's not quite in the form you want, first think, is there another way I could write this? So I'm not doing the derivative yet, but I'm rewriting the problem as x raised to the negative 4, because that is the same thing. Now I can use the power rule to find the derivative by bringing the negative 4 in front and then subtracting 1. Be careful with negatives. Negative 4 minus 1 would be negative 5. Okay. Another important rule to know is that a constant will always give you a derivative of 0. And that should make sense because remember, derivatives are really finding the equation of the slope. So if you think about the line y equals 3, that is a horizontal line. And horizontal lines have a derivative or a slope of 0. So it should make sense why the derivative of something like this will always be 0. So the derivative of a constant is 0. If you have a constant times a function, you don't really need to do anything special. It's just when you bring that number out front like we've been doing, there's something already there to be multiplied by. So in this case, I would do 4 times 3 and then subtract my 1. So that's it for the basic power rules. The sum difference rule sounds fancier than it is. All it's saying is if you have different terms being added and subtracted, you can just do the derivative of each one separately. You don't have to do anything special. So if I was doing the derivative of this one, I would first think about 5x to the third. I can do the power rule. So 3 comes to the front and multiplies. 3 minus 1 is 2. And then the derivative of a constant is 0. So really, 15x squared would be my derivative. Let's do another one. First, I noticed that some of this is written in a way that would make it hard to use the power rule. So the first thing I'm going to do is rewrite this problem. I'm going to remember that the square root of x is the same as x to the 1/2 power. So I'm not doing the derivative right now. I'm just rewriting the problem. And an x in the bottom, remember, is the same as a x to the -1. Now it's set up better for me to do the power rule. In this case, I know that I have a 1, so the 24 will still be there, but x will turn into x to the 0 power, so it really goes away. So basically, whenever you have a number with an x to the first power, your derivative is just that number. Minus, bring the 1/2 out front. 1/2 minus 1 is a -1/2. Here, the -1's going to come out front, so it's going to become a -5x to the -2. This is our answer. You could rewrite it by now moving the things with negatives to the bottom, but I'm just going to stop there because I'm just trying to show you how to use the power rule to find derivatives. So remember that you don't really have to do the power rule for a constant. Just remember it's always 0. And if there's a number out front, it's just going to get multiplied when you bring the exponent in front. And when you have stuff being added and subtracted, you can do each derivative separately. You don't have to do anything special. So hopefully that helps you get started on finding derivatives. If you need any more help, let me know.